Hello, thank everybody for coming. I must apologize to the organizing. I must have missed the email where they said to use the template, because I noticed everyone else was using a template. And here I have a templateless slide deck. More than likely I would have messed up the template anyway, so. Okay, I think I titled this Automating Execution Plan Analysis, because that's what I built something to do. Like, why would we do this? One reason you might want to do it is if you want to do comprehensive indexing. I think there are other good sessions on performance tuning, how to index. So this is a slightly different angle on indexing. My slide deck is available on my website, QDPMA.com. I think I should load it up onto the SQLRally website as well. Okay. All right, I'm sorry, let me see if I can use this. Oh, hold on. A little bit of my bio, but you can find it on the web anyway, so I don't really want to spend... I tend to run long, so I'm going to try to skip the preliminaries. Objectives, yes. I may want to change this a little bit. Okay, non-objectives, because I got criticized this before. Like, why didn't I do such and such? I'm not a big believer in rules, probably because I'm a big breaker of rules. So it's my feeling is that people forget the reason for the rule. They like to memorize rules. I have a suspicion it's so they can say, I follow the rules, so it's not my fault when something breaks. I would rather fix whatever's broken. I don't care who broke it, even though I may mention whoever broke it. But that's, I guess, a politeness failing on my part. Okay, more preliminary. There are some things that are still important. They're big topics in themselves. So whatever I say here does not override any of this. I recently had a discussion on one of my blogs. Someone was saying in the business world, time to market is of overriding importance, that they'd rather tolerate mistakes. So if you want to make mistakes in these important things, just try to fix it before it becomes too late to fix. Okay, one more preliminary. In the big picture, I don't view this as super complicated, but it's not trivially simple either. In performance work, people have a tendency to jump on the one or two things because it seems reasonable, but there is enough complexity in SQL Server. It may not be that simple, so you have to consider a number of different possibilities. This is most of the ones I could think of. If anybody thinks of something else, please let me know. And I kind of laid this out to show how the query optimizer is the center of this, but we access it through the execution plan, hence going back to the title. Okay, so the title's Automating Execution Plan Analysis. The other thing is comprehensive indexing. The first part of indexing is you got to get the primary key, the cluster key, which may or may not be the primary key. You should really try hard to make the cluster key unique and not too wide, but I won't go into that because there are other talks for that. You need good non-clustered indexes. But not too many indexes. I don't like to put up hard numbers. Brent's talk yesterday, he said 5. I'm not convinced you can say 5 because it's whatever it needs to be. It needs to be as many as you need or as few as you can get away to meet your requirements. So, and the other thing is, I want to heavily emphasize good, not perfect. Because you can't make it perfect unless you make it too many. So you're going to have to figure out where you can give up to get something good enough for a lot of purposes, but not have too many. Okay. With SQL Server 2005, we now have access to a lot of information we need for performance work easily. We may or may not have had access, but it wasn't easy sometimes before 2005. Oops, wrong button. One that maybe everybody already knows about is dmexec query stats. If you're not familiar with it yourself, you probably use a third-party tool that uses this heavily. From there, you can get the execution plan. Less popular is I don't even remember, DMDB index usage stat. And if I mess that up, please let me know. This basically tells you the indexes, any index that was used since these counters started, which I believe is when SQL Server started. I'm not aware that you can reset it, and if you are, please let me know, while SQL Server is running. So it tells you whether an index was used in a seek, scan, whether a key lookup was involved, an insert update was involved. Okay, so basically you have two independent DMVs that have a lot of information. But how do you link the two together? That happens to be in the execution plan. So that's why it's important. Let's see. A little bit more, yeah, okay, this is just a little bit more detail. So this is just query stats. It has handles for other things. So a pair of DMVs from which you can get the execution plan. One, or it's actually, I think it's actually a function. All right, one or the other. Another to get the SQL. From the execution plan, you can find out what indexes were used and link that to the index usage stats. There are other things that come up. dmexec query profiles is a new thing in 2014. It sounded really interesting. I just haven't gotten around to looking at it. And I find out, I think the next session, I believe, is on this topic. So that would save me a lot of work by just going and sitting and listening about it. Okay, oops. Let's see. I'm sorry, any questions? No? Okay. Okay, if you go to my, if you go to my website, QDPMA.com, a little bit way down, you have a little tool. That's the latest version. You can download it. It's in a zip file. It's an executable. There's no installation. So you just click on the executable. I have already opened here. You enter some information on the SQL Server, possibly the databases you're interested in. Now, you would click this to grind through some execution plan analysis if you're pointing to a live server. To get something interesting, what I do is I actually save the information so you can look at it later. So instead of looking at a live server or my laptop, which doesn't have anything particularly interesting, unless you like American baseball. Oh, okay, it's not popular here. So you would normally run this to get execution stats on a live server. You can right-click so you can open a previously saved file of information. This is a client of mine that I started working on last summer. It takes time to open. And there's various tabs. The first one I want to show you, oh shoot. Give me just 1 second. Shoot, no, that won't. I don't know if this is going to work well. All right. Yeah, I didn't make this zoomable. Okay, this is a summary of the tables in by database. I happen to point it to only one database. You can collect on more than one database. It's sorted by size. So I picked reserved space, which is data plus indexes. So when I got there in June or July, there was 3.6 billion rows in their database. The reserved space was 3.4 terabytes. The data was 1.5 terabytes and 1.8 terabytes of indexes. This is a batch processing. It's actually a mix of batch processing, which is basically transactions driven by a batch process as opposed to live users. So it has characteristics of small queries, and there's some occasional data warehouse style queries put to a different set of tables too. So if it's a transactional type database where you're doing a lot of updates, you do incur overhead. Oops. All right. You do incur overhead with indexes. So basically, one of the first things I noticed, well, that's a lot of indexes if you're doing transactions. At the time, I didn't know it, but okay, let me go back to the slide deck in a minute. I'm sorry. So I had pasted this in, and I think I increased the size. Oh, shoot, sorry. Too much. All right, hopefully that's a little bit more readable. So, okay, so this is July 2004, last year. 1.5 data, 1.8 terabytes indexes. The key tables, yeah, so, okay. This one, and more this one. These are the key tables. They have, between them, the first one up there has 21 non-clustered indexes. Another one has 18, 14, 4, and 14 non-clustered indexes. So if you look at my tool in the Tables tab, a little bit over, this is whether it has a clustered index. This is the non-clustered index count, even though it says IXCNT. Didn't want to waste the pixels to put in N for non-clustered. So one of the active transaction tables has 21 non-clustered indexes. The table reserve space was 700 gigabytes, 120 of which is data, 644 is in indexes. Okay. Sorry, I'm not used to using this. Okay, so the next tab over is a summary of the indexes. The tables tab, I was sorted by space reserved. Indexes, I sort alphabetically, leading with the schema and the table name, which is nar split. So the top row, that's the cluster key. Over here is the index key columns. Next is the include list columns. So SP help index does not show you include columns, is mildly annoying. You can write your own thing. I think I have an SQL script on my site that basically shows you a little bit more information than SP help index. Okay, so the table, so the index keys, I wrote something to pull out the index keys. The number of user seeks, that's just from seeks. This one here is scans, updates, and one over is the number of updates. So you can see, let me see. So this is 21, this is the cluster key and 21 non-clustered indexes. You can see the usage is concentrated on the cluster key, 1, 2, 3, 4, maybe 5 of the 21 non-clustered indexes. And yet we have to update, heavily update, most of the other non-clustered index. Whenever you insert into a table, you must update the non-clustered index. If you update a table, you have to update any index for which you changed the data. So you can see that there are a few indexes which have columns that probably didn't get updated. So there's less overhead in maintaining those. This index name here might be their convention, or it might be Index Tuning Wizard recommendations. My understanding is they did run Index Tuning Wizard. So it wouldn't help me to badmouth Microsoft, but you kind of have to know. Index Tuning Wizard is a highly automated thing. For that, they call it a wizard. It is not that you're getting someone who is intelligent to help you with indexes. He's just doing the work. It is not incredibly intelligent in the index recommendations. So it's more like index tuning, a beginning DBA who knows enough to be dangerous. And I've suggested to Microsoft I can give them much deeper advice on how to build your indexes, but they never take me up on my advice, probably because I preface it with, you screwed up big time. It's why I'm a consultant and I don't work for a company full time, because after a while they would like me to go away. Okay. One thing that's obvious is many of these indexes have a lead key, have the same lead key. That's a dead giveaway. These indexes could be consolidated. Some of these indexes are outright not used in seeks. They are used in scans, which means you weren't using it for an index seek, but you just needed something really narrow so you can scan through to find something which may or may not be the index key. It might be one of the cluster columns. It could even be the primary key or the cluster key that's included in every non-clustered index. You needed a scan. So if you got rid of this scan would have to go somewhere else. Okay. Another thing is, just because it's used, it's not entirely, it doesn't mean it's the right choice of a cluster key. So the cluster key is actually the primary key, which is the row GUID. One thing you notice is many of these indexes lead with another column. And by asking them what these columns meant, basically this key column here is the parent of this value. That's a pretty strong indicator to me that my cluster key should probably lead with this, followed with that, and this would just become a unique non-clustered index or primary key, your choice. If you make it a primary key or unique constraint, you cannot have include columns. If it's a unique index, it can still be used to meet the requirements of foreign keys, but you can have include columns. So, I went through and I got rid of their primary keys that were non-clustered and replaced them with unique non-clustered indexes. Then I found out there's some tool out there that looks for the primary key of a table. It was one of those, it might be LinQ, so I broke that. Sorry. Let me see. I do want to show, let me get to that a little bit later. Okay, so I got there in like June. The sheet I just showed you was from July. It takes, before they would let me just ruthlessly rebuild all their indexes. They wanted me to test it out in several systems. It went through several cycles. It wasn't until September or something before I could put my first proposed index changes into production. But I forgot to save a data set that shows the right thing from September. So I'm showing you, so this up here is the table summary. Oops, sorry, I went. this here is the table summary from December of, so of the original 3.6 terabytes when it was 3.6 billion rows. Now the database is probably 30% larger in terms of rows, but the reserve space is 2.3 terabytes. The data size grew a little bit, but you can see instead of 1.87 or 8 terabytes of indexes, plus 30% row growth, I now have 500 gigabytes of indexes. More or less, I had most of the core indexes I needed at this level. What used to be the largest table is no longer the largest table in reserved space. It was down from 21 to 6 non-clustered indexes, and a reduction in some of the other tables as well. Let's see. So this is the table with the that had 21 non-clustered indexes. I switched the cluster key to the lead with a parent table because the primary modus access is give me all the rows that belong to this parent. So I would rather use that as a cluster key rather than have this as a non-clustered index with a fat include list or have to do the key lookups to get there. What was the primary key clustered is now a unique index, non-clustered. I do have a few include columns. I think I wanted to get rid of them. This is a little funny in that it looks like it goes against what I just said. I have non-clustered indexes, not only with repeating keys, but also it leads with the same as the cluster key. This is a slightly more sophisticated thing. I use this to get rid of a sort in a transaction. I think in Brent's talk, he talked, one of his execution plans had a sort. He did something, it got rid of the sort, it was much improved. The sort may or may not be a heavy element of your query. In this case, I thought it was important enough that I made a non-clustered index for it, even though it led with the same key as the primary. You can see there's two non-clustered indexes that are not used frequently. This was from running their key transactions. They told me that these are necessary to support certain user queries. Depending on how they work, one of the things I will look into is, hey, do you only need these indexes at a certain time? Because if so, feel free to drop them prior to running your transactions and then reapply them after to avoid doing a whole lot of updates. But you can see that the number of updates is relatively low. I just let it go. Okay. Let me point out that this database, every table had a unique identifier as the primary key. This includes both the fact type tables and the dimension tables. A unique identifier is 16 bytes, right? The natural key for some of their dimension type tables was 1, 2, or 4 bytes. So instead of using the natural key that would have only added 1 to 4 bytes to their fact table, they added 16-byte GUID keys. Now, my previous experience was with unique identifiers was that if I apply table compression, you don't get anything. Apparently, that's not true if it's the same values are just repeating regularly. So I did not recommend compression initially. One day I got tired of these giant tables. Let me just see what kind of compression ratio I could get. Turned out I could get 6:1 or something, and for 6:1 I'll take it. And when I did, the data size shrunk down to 548 gigabytes from 1.5. The indexes remained about the same. The bigger deal is so even though my total database size now is just under 1 terabyte, my core tables are like 200 gigabytes, which happens to fit in memory, and that was a big deal. Yes. Page compression. I have never used row compression.
Did you use row compression the first time where you didn't get the result you expected?
I have never used row compression. My thought was, if you need compression, go for it. A long time ago, I looked into the impact of compression. I ran single-threaded queries, all data in memory. The overhead for compression was about 40% higher CPU. If compression meant that your database went from your core active data goes from much larger than memory to mostly in memory, the value of that far outweighs 40% CPU. Because in the execution plan, people are aware of the CPU and the I/O. That has, don't worry about that. That's kind of irrelevant. If you have to do a disk I/O for one page, that's several times higher than the cost if that thing was in memory in terms of CPU cycles to do an 8 kilobyte. It's not just to do an 8 kilobyte I/O, it's for SQL Server to figure out what page to evict and then the I/O to load it. So if I can get a significant reduction in I/O, the 40% CPU from page compression is nothing. You could probably argue that there might be some circumstance where row compression might be a balance in between. I'm billing a client a lot of money, so I can't investigate all options. I'm not discouraging them from investigating themselves. It's not, but it's not in my recommendation that they invest my time to do this, because I don't think the gain is going to be, I don't think the information is going to be hugely valuable. You might ask, why don't I charge less money? It's not that I need a lot of money. It's more like if they didn't pay an arm and a leg such that it hurt for my services, they might not think it's important. It's not my fault. I just do what's necessary to help them. Okay, where was I? Oh, okay, I'm sorry. Maybe yes.
Non-clustered indexes contains the cluster key.
Yes.
You explained that lead index keys must be not repeated.
Could you speak into the, sorry.
Non-clustered indexes contain the cluster key. So
yes.
In the example, non-clustered index has the cluster index key again.
Okay.
It is needed, and you explained the lead index keys must be different the others. So can you explain it again? Why you used again the session ID?
Okay. Let me say. Let me pick. Okay. This is my cluster key. Let's look at this index example here. This is my only key in the index. So the actual index will be this column, followed by this column, followed by that column. Now, suppose I built an index that specified this, and then my actual index, it would lead with this, followed by that, and then this. So here what's happening is I want my index to lead with this, follow with that. I'm sorry, it's not apparent that this one is a filtered index. So that was my convention for a filtered index, is to lead the name with FX. Of course, they had hard-coded index hints, so there were a few filtered indexes that were named IX. Okay, my filtered index is on a column that's isActive. Notice the isActive column, it does not lead with isActive, because I'm saying the query is where isActive equals 1 and this equals something. So the isActive 1 doesn't provide a lot of selectivity for me. It does help in filtering because I only have to have about a tenth, less than a tenth of the table. There are some tricky I do some strange indexing, and that's a separate discussion. So so it would take this discussion a little bit off topic, but while I'm off topic, remember I said earlier, in single-threaded queries, the data in memory, the overhead of page compression, I measured it at 40%. I also looked at parallel queries, and if you have a parallel query, it's possible that the compression overhead is 0. There is no difference in performance in doing a data warehouse query between uncompressed, raw data, and compressed. The compressed data is a lot smaller in storage space. Anybody want to venture why? Okay, no one wants to step up. So apparently when you increase the degree of parallelism, there is contention for some resource or the other. So that when you go to 2 CPUs, you get nearly double the performance. You go to 4 CPUs, you don't get 4 times, you might get like 3.6. At 8 CPUs, it might be, I don't know, 6 point something. It varies by exactly what operation, how much contention for resources you have. In that example I cited, it turned out the extra CPU of the compression just happened to remove the contention in a parallel execution plan. So the overhead of compression is a really tricky matter, okay? Let's see. Okay, I think I summarized this, but let me show you something. Let me get back to the tool that I used to generate this data. I showed you one tab was the summary of table information. The next tab I showed you was index usage. So let me scroll down to the table that we were interested in. All right, so this is the table we're interested in. Here's the cluster key, the number of seeks, the number of updates, and then you remember the other DMV of interest was DMExec query stats, from which we could dig up the execution plan. So I went through all the top execution plans, and when I read through the execution plans, I noted what index it used, and I marked it with this number. So that means the number 1 execution plan used this index. The number 12, 50, 75, 83 used this index. If you're just interested in your top queries, you can look at the execution plans, see what indexes you need. If you were just doing some basic index tuning, you could look at DM, DB, index usage stats. You can see that if certain indexes aren't used after a significant period of update, such that every query that could run, has run, it might be safe to drop some of those indexes, especially if they were generated by Index Tuning Wizard. But what about the indexes that are used infrequently? If you drop those, like something might blow up. But if it's used infrequently, it's probably not ranked very high in DMExec query stats. If you want to grind through 1,000 execution plans, you can do that. If you want to pay me to do it, even though it would burn a lot of billable hours, I might still refuse. But write a program, read through the execution plans, find all the indexes. With this thing, I can grind through 2,000 to 3,000 execution plans, and I can find if that index was in a plan, in the plan cache, I can find it. And then you can look at the query and say, oh, hey, this one can actually use that other index. It just happened to pick this one because it's a little bit better for this query, but the other one was good enough. So you remember my previous emphasis, it's good enough, not perfect. All right, well, so let me switch to the February date. So, oops, sorry. I showed you table summary, index summary. So this is a summary of DM exec query stats. In the most current version, oops, I collect a lot of information. I don't always know what to do with the information. I'm just collecting it for now until I figure out what to do with it. So right now, the top level is a summary. So there were, in this particular example, there are 276,000 CPU seconds, or worker elapsed, is it worker time, in DM exec query stats. If you use stored procedures, I roll it up by stored procedure. This procedure was the top one. These are the statements within the procedure. The statements are currently not in the order of occurrence, but by CPU ranking, or CPU or duration ranking. The offsets are available if you could put it in order. I might later switch to put it in the order they occur if that's more useful. Let's see, in this morning's session, is it Maggie? She talked about people who did not use stored procedures, in which case you have all these little queries that get a different execution plan. But the DM exec query stats has query hash, which removes the literals. So I attempt to group by query hash when first, and then determine whether it fits within a stored procedure. I do think that if you have the same statement that occurs twice within a stored procedure, I might show it as one line item. So basically I can, just by running this, I can give them a pretty good picture. This stored procedure is one of the top resource consumers. I believe this is from SQL Sentry. I don't know about this one, but this one I believe is from SQL Sentry, the performance monitor. Yeah, it's a little embarrassing when your own query bubbles up to one of the high resource consumers. So I don't show my own queries, but it doesn't, I deliberately rigged this to not generate too much of a load so you can run it on even a busy system. And the other reason it doesn't really matter is because this SQL Server has been running for like 3 months, and this query, the plan doesn't recompile. So it's the execution statistics for 3 months of runtime, whereas this is for like 1 week of runtime. So it's a little misleading that a SQL Sentry query is up high. It's irrelevant, okay? Here's a table valued function. Here's another procedure. So pretty much with a click, I collect a lot of information. I try to collate the information, format it as best as possible. There are some tools out there that attempt to rewrite SQL for you. I do not believe any of those push-button solutions really work. You might say that I'm biased because if they did really work, I would be out of this line of work, and I might have to do real work, which I kind of vowed never to do again. Okay, so how am I? Oh, how about that? I didn't run over this time. That's the bulk of it. Oh, in previous talks, I did heavily theory. So I was told a lot of people want real-world examples, so that was what I gave you. I finally had a client with a very good real-world example. And I looked at it. There was nothing in there that is super sensitive. Apparently, some of the other projects, the table names had things that might have caused embarrassment of some sort, so I couldn't use that as an example. This is an insurance application, if anybody is familiar with the terms in insurance. My understanding is that the world of insurance is very different from any other type of database, which is why they normally hire from within the insurance industry. When I looked at the logic, man, this is pretty complicated stuff. They had execution plans that were 30 megabytes in size. It's kind of crash Management Studio, or make Management Studio highly unresponsive. I don't know if SQL Sentry's Plan Explorer is better at handling those. Okay. Anyways, it turns out their database had performance metrics going back to, reliable metrics going back to 2013. They had data going back before that, but the processing was erratic because they were still working on the code. Back then they were on hard disk storage. A single thread could process at the start, it could process a little over 10 transactions per second per thread concurrently. So they would run like 6 to 10 threads concurrently. But over time, it gradually degraded to the point where they were hurting. This degradation I believe, is a combination of the database increasing in size, so less of the active data is in memory, more disk I/O, plus index fragmentation as you go over time. If you rebuilt the indexes, my belief is you'll recover some of this downward slope, but not all of it, because that part is the increased disk I/O. What else did I want to say? They were hurting real bad. Their first measure was to buy a Violin storage system, which is flash. I sometimes say SSD. Violin insists they're not an SSD. That depends whether an SSD is a solid-state disk or a solid-state device, because they are solid-state. So they correct me every time I refer to them as an SSD, so I'll elaborate. They bought the Violin system. They got about a 10x improvement immediately. Then performance started slowly going down again as the database got bigger and the indexes got more fragmented. And remember I said every table used a unique identifier as the key? Well, that's as good a choice to get fragmentation as, but it does do certain things for you. You just have to balance whether you want the penalties over the benefits of a unique identifier. And you certainly don't want to use an identifier in a dimension table when the natural key is 2 or 4 bytes. And not only that, the natural key tells you a lot, whereas the GUID does not. I mean, you can look at it and you know what the query is about. Okay, so somewhere around here I came in, I made the recommendation on indexes, September. We implemented it. Just by reducing the indexes, I think we got like a 30% performance gain. The following month, the performance went down, but that was because this definition is not fixed. In this particular month, they were doing heavier transactions. And then the following month, it recovered. About this time, I applied compression. And as far as I could tell, there was no penalty. There was probably a 10% performance increase with compression, mostly because of the heavily reduced disk I/O outweighing the 40% CPU for in-memory access. I kind of told them at the beginning that, if you give me a year, I could probably work on it. I could probably make your application run on a hard disk. And at this point, I got their hard disk performance up to about 30, more recently, about the 50 level. So roughly what they got with the Violin, but the very heavy index overhead. So the thing is, the work for doing a lot of this was heavily simplified because I had a little tool. So let me just show you. Here it's pointing to all databases. If you only want a single database, you click, it collects the information. You still have to do a bit of this run fast because there's not a lot of activity on my notebook. let's see, on a busy production, in their case, in a busy production system, they might have 4,000 or 5,000 line items in DMExec query stats. I put a filter on because when the total worker time is less than like a millisecond, even 100 milliseconds, it's probably not a big deal. I've noticed third-party tools do unfiltered queries to DMExec query stats, and that's why their own query is high up on the list of your top resource consumers. So they don't know what information you don't need to look at. In the big picture, it doesn't really matter, but anyways, you click, it runs. Here it runs in about a minute. If I had to gather about a couple of thousand execution plans, it might take 3 or 4 minutes to run. I deliberately I introduce delays between steps in my program just so I don't generate a CPU spike on my own. So you click, you run, you have the tables summary. You can see that there is no index usage because I didn't run anything. I'm sorry, this was the index usage. This is the query stats. The only thing in the execution plan are pretty much system level queries because I didn't run any queries on it. Let me just show you. Okay, so this is not hugely user-friendly when you see the DMExec query stats. That means go after DMExec query stats. But really what this thing does is it parses execution plans. There's different ways to get execution plans. I think one is is it exec plan cache? Okay. So I think, is it Maggie talked about that this morning? So there were columns in the exec query, the plan cache. I didn't know what it meant, and she explained it. So maybe I need to re-listen to that and see if I can make something useful out of just using the plan cache. But by the way, if you want a list of the stored procedures in a given database, you write select name, also schema from sys.procedures, right? Now you have a list of stored procedures. You can say set estimated execution plan on, right? So you say, hey, this is my procedure, give me the estimated plan. So to a degree, I can just generate the estimated execution plans for all the stored procedures in a database. So is when someone changes logic, I can see if it impacts any index usage. There's some limitations in that I don't have parameter values for the stored procedures, which might affect the execution plan. And as soon as I built this in, someone said they wanted to run it. They had 6,000 stored procedures in their database. A lot of them were non-functional. A lot of them called layer after layer of procedures and functions, so that the combined execution plan size was probably over a couple of gigabytes. And I was running the 32-bit version of this, and it crashed. So what I did was I introduced something called SQL Source, which in the config file for this, you can specify a query that brings back a list of SQL. So basically, I partitioned the number of procedures. Or you could just basically, if you have a key list of queries that normally run against your database, you can basically just generate the estimated plan, or you can execute, you can get the actual plan. There's a lot of information in the actual plan, particularly concerning parallelism, but I don't have the opportunity to work on that. So one of the problems in a parallel execution plan is your work uniformly being distributed among the working threads? And you can use information in the plan to investigate this, but I have not done so yet. So this is a tool, it's on my website, it's free to use. I make reasonable effort to support it. Europeans, it cause a lot of breaks in my code because you use Unicode here, and they have the funny characters that I didn't handle correctly because I'm an American, sorry. But I think I've gotten rid of many of them, so feel free to use it. when you run it, let me just show you something. So originally it just had the executables. When you run it, this file here is the binary data of everything that's in there, so I can open it up again. I also saved the information to Excel, because let's face it, Excel is one of the best data analysis tools out there. You can do things that you don't want to write into a query. So my feeling is you could fix a lot of common problems, performance problems, with the information collected, something that can be easily zipped. So if you are like, I don't know, a consultant here supporting many customers, you just ask them to run this remotely, or you could you can ask them to run it and send you the results. You could remote in, run it yourself, and bring it back. My recommendation is people just run it like once a week, once a month. If you don't have time to look at it, don't, but whenever they have a problem, now you have the execution plan of when it's a problem, the execution plan when it wasn't a problem. So you don't bother looking at it until lets you backtrack. If you want me to look at it, first look through the Excel just to make sure there's nothing sensitive about your client. Okay? So let me show you. So the same tabs, except in Excel, it's in the bottom. The table summary, the index summary, and the execution stats. So what's the difference between this and a third-party tool, performance advice tool, whatever? They tend to be a lot user-friendly. They generate great-looking charts. You can use them to generate great-looking charts. What they seem to miss is the importance of the execution plans linking the SQL to your index usage. It's not a secret. I explain it to them. They don't bother implementing it. It is something that I do. And I think it can make your life a lot easier. I'll tell you one of the reasons I built this. As a consultant, they always want to talk to me before they'll try to describe their problem and see if I can answer what their problem is or if I'm the right expertise. And generally, I found that what they tell me may or may not be true, but it's really not it's what they perceive to be the symptom of their problem. It may or may not be the root cause. And they haven't provided me any information as a root cause. So I can't give them any meaningful advice. There have been rather embarrassing circumstances where I have flown across the country, should I harass on Dell? I don't know, okay. Something horrible happened, okay, get on a plane, go to Wisconsin. That's where a lot of Scandinavians live. So they were certain it was a storage system failed. So I look at it, no, I think your storage system behaves exactly the way the configuration says it should behave. I mean, it was like 30 disks, this many random IOPS, this much sequential. Let me look at your query plan. Wait a minute, this query plan generates random IO. When it worked before, it was a scan. And what happened was they did something that changed statistics. So anyways, I flew for like a long distance for a 4 or 5 day engagement, but their problem was you just update stats, you don't have a problem. The contract was already signed, do a week's worth of work. You got anything you want me to do? So basically now I really ask people, it's not that I don't like talking to people. I mean, you probably sense I'm not always that sensitive. But with this, I can tell them a lot more up front as to the likely cause of their problems. And if it's really simple, I'd rather just tell them, look, just do this and you don't need to worry about it. Because I like to work on the more substantial, there are plenty of people with substantial problems. And that's the reason you should bring me in. Many of you probably already do that yourselves, and this, I think, is a good tool to use. Let's wrap it up with that, okay? Hope this is useful. Yeah?
Could you show an example of using that SQL Source to go?
Well, to run something. I believe it is pointed correctly. Estimated, or let me run estimated first. Let me also show you the config file. If I can find it. Yeah, that's the config file. So there's some, you can save some information in here so you don't have to enter it because your production database doesn't change. Down at the bottom, there is a query that points to a table that has the query name. It happens to be the queries used for the TPCH benchmark. And if you recall, I hope I pointed it to the TPCH database. When I ad hoc, you always make mistakes. I'm sorry. In this case, it was the TPCH queries, but I put the queries inside of a stored procedure. So now, basically, there are 22 TPCH queries. This is this is from the plan cost for the individual queries. This is if there's a scan, how much is the I/O? If you look at an execution plan, you see a scan or large seek, and you see an I/O. Multiply that number by 10 for the approximate megabytes of data you have to touch. Mild curious item. Let me now point to, so that generates the estimated plan for the list, and this one will run the query to generate the actual plan. I think it should take a minute to run on my laptop. It's the TPCH at 10 gigabytes. I do have a SATA SSD, because if it was hard drive, it would take forever. If you've seen me on SQL blog, I constantly bitch to hardware vendors that I need a special laptop that has a server class SSD. For your efforts of doing this, the market size might be 1 or 2. Could you do it anyways? Yeah, you can try. So you can see this first query, 270 seconds of CPU, 36 seconds of duration. This is a quad core with hyperthreading enabled, so it appears as 8. The second one ran in 1.7 seconds. So I might be wrong about it. It's more than 1 minute because this first one took 36 seconds, and the subsequent ones take a little bit longer. Let's see. So in this case, it's 1 execute. CPU duration. Total seconds is a little funny. I think I'm attempting to add up the compile time, but I might not be doing it correctly because that's why it reads 18 versus the execution duration of 36. Let's see what that column is. You can see it's been a while since I've run it in this mode. I don't have the mouse yet. Oops. I'm sorry, how do you
specify the queries you want to be?
Put the queries you want into a table, okay? And the query, in the config file, you write an SQL so that it can get the queries, and your query must be written in a way so that I can do a select count, like parentheses, the query that brings back the queries by name. This is so I can get a count of the query. So if you actually want to use this, you might need to send me a couple of emails, and I'll try to explain it. And when you tell me what I did was not very user-friendly, I'll see if I can I don't understand sometimes, because I'm writing the code. So you need to tell me what you find unfriendly about it, and then maybe I can, that you wanted that? Okay. Yeah, I can do that. Well, actually, I'm not that good of a programmer, so. Okay, so not only do you have the execution statistics, but in a subfolder, you have the execution plans. And you can click on it, it'll bring Management Studio, takes about 15 seconds to launch. There's a DLL somewhere in the SQL Source tree that generates the graphical plans. I've asked Microsoft nicely, can you give me the APIs to access the DLL? They say, go kiss off. Who's the New Zealander? I think it's Paul White. He's done a lot of reverse engineering, so he's a real coder. And I've asked him, can he do it? And he says, no, he's tried and can't. The SQL Century guys, they have their own Plan Explorer. I've told them it would be really nice if I can point your thing to a directory, then scroll through the execution plans. Apparently they're not hugely inclined to listen to my advice. So they have their own ideas on how to go about query tuning. I'm not a big user of weight stats. I think, is it in Maggie? She actually explained how to use it, which I didn't know before. But my feeling about weight stats is useful to Microsoft because they have the source code. Microsoft does not give me source code access. I don't feel that the weight stats are hugely useful. Just show me the query that's having problems, and I'll find out either the indexes, the SQL, or the statistics to fix it. Because I'm interested in what I can fix. Okay, so let's go back to the tool. So I'm sorry you don't have the SQL visible because I pointed it to the stored procedures. But here I just executed a list of queries. So now there's only 22 TPCH queries. Your apps, you might have several hundred important queries. I'm sorry, it's not just queries that are important. I would include all your queries so I can find out every index that's touched. And you may also want to include certain queries more than once with different parameter values. You might need an option recompile to force the recompile to look at the different possible execution plans for each piece of business logic. And now you have an automated means of generating what indexes are used every time you change your logic. Because you change your you have a table that you update frequently that needs a lot of indexes. You go hunt those queries down. Maybe if I can rewrite it, I can get it to use fewer indexes and get rid of some update overhead. So I think this is good for both developers and DBAs. I'm sorry, go ahead. Okay, I learned to program in Fortran days. My ability to learn has kind of diminished since, so the coding is really ugly. I'd really like to find an expert object-oriented programmer, because I've seen some of those codes and they can change things really quickly. If you change something in my code, it breaks, because if you're willing to commit, if you have serious programming expertise and are willing to commit time, it's like you have a government job where no one knows that you don't really need to do any work, so you can do what you want. Hey, that's really great. I would consider, I don't want to give it out to anyone who just, because they say so. Show me that you have real commitment to this, and it's something. I give it out to my consulting clients, but most of them don't care. One guy had his own testing tool. I looked at, wow, that's pretty neat. But he doesn't do execution plan analysis, but he didn't have time to tie the two together. So are you a good programmer? It's in C#. I did have one offer, but he was a VB programmer, and he said, I want to convert it to VB. It was enough of a pain for me to learn C#. I did not want VB. No offense against anyone who programs VB, but I'm limited in my ability to learn new things. So, ma'am, did you have a question? Okay, so, Okay. Oh, here's my. This is, oops, sorry. My website is here, QDPMA.com. It stands for Quantitative Database Performance something and Analysis. One of the things my complaints when I got into database performance is a lot of people seem to treat this as cooking. You know, like, let me try this, let me try that. Isn't there any quantitative analysis to support this? There was very little of that in the SQL Server world. There was a little bit in Oracle and DB2, that other thing. There's a Oracle outfit, I think Hot Sauce. These really sharp Oracle guys, they're proposing the notion that just count logical IOs. So, yeah, that sounds interesting, let me try it. And how about that? Logical I/O has no bearing on true query cost. So I wrote something on that. A lot of people came back with hate mail saying, you know, like, I've been doing logical I/O forever. It's worked for me. I follow it blindly, even though I explained why it has no consistent meaning. So, okay, fine. Just feel free to download it if you're willing to commit to it. Okay. Okay, I would like to get it cleaned up, and then we can make it open source. So no one sees, you know, like, God, if you program like that, I don't want you touching my... You know, because I complain a lot about other people running SQL, but if they saw my C#, they would laugh. So, you know, isn't that like pot calling the kettle black? Okay, so I hope this has been helpful. And I will stick around for more questions. I need to get out of Kevin's way. Thank you.